here to teach the intro to the chain rule. You know what I'm saying? Yeah, calculus block 5.
So, just before we begin the lesson, some important terms to know so that you can follow along easier. Just remember the chain rule, which is the derivative of what you're solving for, f prime of x, is equal to f prime of g of x times g prime of x. We're also going to use the terms inner and outer law. So when you're looking for the inner derivative, this is going to be a word that's interchangeable with the symbols g prime of x, and outer derivative is interchangeable with the symbol f prime of g of x.
Alright, so let's begin the lesson.
Alright, first we're going to start off with something pretty basic. This is a pretty easy example of the chain rule, 2x squared. So I'm going to start off with showing you the inside function and the outside function. So when finding the two components, we can start with the outside. The outside is always going to be what's being applied. So in this case, there's a square root being applied to the 2x. This is also easier because it's actually on the outside. So for the outer, we're going to write x squared. Basically, the x here represents what's inside the parentheses. And then for the inner function, you're just going to take what the outer function is being applied to. So in this case, it's inside the parentheses, and that's going to be 2x. So now that you have the two components, it's going to be pretty easy to just plug it into the chain rule. So before I apply the two components, the chain rule, so you're going to be finding the derivative of the equation, f prime of x equals the derivative of the whole function, also known as the outer function. So it's going to be f prime of g of x. And you're actually only going to be taking the derivative of what's on the outer layer and then leaving what's on the inside as itself. And this is going to be multiplied just by the derivative of what's inside. And this is g prime of x. Now if we apply this, we're going to take the whole derivative, so what's on the outside, we're going to bring down. So we know that the derivative of x squared is 2x, so we're going to bring the 2 down. So it's going to be 2 times 2x. And then this is going to be to the first power, since you subtract 1, but we're going to just leave that for simplicity's sake. And then you're going to multiply this by g prime of x. So this is just the derivative of what's on the inside. So the derivative of 2x is just going to be 2. We can simplify by multiplying numbers. So 2 times 2 is going to be 4, 2x. And then simplify once more. So your answer is going to be f prime of x is equal to 8x. And it's as simple as that. Just plug what you know, the inner and outer function, into the chain rule and multiply.
Moving on to another problem. As Professor Aguilar taught you before, with the chain rule we like to split it into two components. So we can split it into the inner function and the outer function. So in this problem, sine of 2x, we're going to split it into the inner and outer function. So in this one, the inner function is 2x, as you can see here within the parentheses. And the outer function is sine of x. Now that we've split them into two components, we can derive this. So f of x equals sine of 2x. So I'm deriving this as Aguilar pointed out before. With the chain rule, it's going to turn into f prime of g of x multiplied by the derivative of g of x, g prime of x. Okay, so now it's time to derive the function. So according to this rule right here, the f prime of x equals derivative of the outer function, so sine, so the derivative of sine is cosine, so cosine of x, but put in the parentheses, g of x, I'm not going to derive it, so just the inner function, which was 2x in this problem, and then we're going to multiply that by the derivative of the inner function, and using the power rule, we know that the derivative of the inner function is 2.
Remember to simplify this answer by bringing the 2 in front of the cosine. This will make the order more clear. In this next example, which is 8x cubed plus 3x all to the 13th power, this is an example where you can use the product rule because it would take a lot longer to multiply out. You would use the chain rule and it would be much more efficient. So what we're going to do is once again split the function into its two components. So as we know, inside the parentheses we have 8x cubed plus 3x. And then on the outside of the parentheses we have x raised to the 13th power. So since we know from our chain rule, we just take the derivative of the entire function. So that means bring the exponent down to the front. And then the exponent will be reduced by 1. And then multiplying this by what's inside the inner function. So we take the derivative of 3, bring it down, 3 times 8 is 24, x squared, and then this is simply plus 3. And add the parentheses, and this is your final answer. So
Alright, for the next problem, we're going to change it up a little bit. Add square root in this one. Yeah. So in this one, we're going to once again split it into two components. So the inner function would be x squared plus 3, and the outer function is square root of x. Now, once again, to find the derivative, we're going to use this rule, f prime times g of x times g prime of x. So, well, f prime of g of x times g prime of x. So f prime of x equals, for the first step, we're going to rewrite this into a form with exponents so it's more clear, easier to do. So we could rewrite square root of x squared plus 3 as parentheses x squared plus 3 to the 1 over 2. So next we'll take the derivative. So using the power rule, move this up to the front. 1/2 times x squared plus 3. Once again, f prime of g of x. As you do that, reduce that by 1. So this would be to the negative 1 over 2. And then all multiplied by g prime of x, which would be 2x. And then to simplify this, you know that 1/2 times 2x would just be x. So we could change that to f prime of x equals x. Since this has a negative exponent, we can move it down to the denominator to remove the negative exponent. So move down x squared plus 3 to the 1/2 Alright, there's your answer, and you can rewrite this now as f prime of x equals x over square root x squared plus 3. And there is the derivative. Okay, here we have a much more challenging problem incorporating the product and quotient rule with the chain rule. So our original function is f of x equals parentheses e to the x times x cubed all over x squared plus 1 end parentheses cubed. So as you can see here in our first step, we derived the outer function, putting the 3 here, multiplying it by the inner function, and then we squared it because of the power rule. 3 minus 1 is 2. And then after that, we got to find the derivative of the inner function. Here's where the quotient and product rules come into play. So first, as we know from the quotient rule, we just take the bottom function, so x squared plus 1, and we multiply that by the top function. So in this top function, we have product rule. So what we have to do is do the first one multiplied by the derivative of the second one plus the derivative of the first one multiplied by the second one. So here that's what we did. So x squared plus 1, that's the bottom function, multiplied by the derivative of the top function, which would be e to the x times x to the third. So we just multiplied the derivative of e to the x, which is just e to the x, by x to the third, and that bracket, and then added that to e to the x times 3x squared, so that's e to the x times the derivative of x cubed, end of the bracket, and then subtracted by 2x, which is the derivative of the bottom function using the power rule, multiplied by just the top function, e to the x times x cubed, and then that's all over x squared plus 1 squared. Here in the next step, we're bringing the same first section down, so it's 3 times e to the x times x cubed all over x squared plus 1 squared. And then here, we're just multiplying these two out, so x squared times e to the x times 3x squared. And then we're adding that to x squared times e to the x times x cubed, and then adding that to e to the x times x cubed plus e to the x times 3x squared, which is just multiplying this out. And then we subtract that by 2x to the fourth. We got 2x to the fourth by multiplying 2x by x cubed, so it's just 2x to the fourth, and then 2x times e to the x, so it would be 2 e to the x, so 2x to the fourth e to the x. And that's subtracted because of the quotient rule. Moving on to the next step, once again we're keeping this section here, and then multiplying this, and to find this, we just multiplied it all out, and after multiplying it all out, you get, so in this section we have 3 times e to the x, as you can see, multiplying these, times x to the fourth, because we multiply x squared by x squared, so that's 3 e to the x to the fourth. And then we're going to add that to this section here, which would be e to the x, because there's just an e to the x, there's no coefficient. Then x squared times x to the third is x fifth, so e to the x times x to the fifth. Now we're going to add that to what's multiplied out of this section, which is just e to the x times x to the third, because that's all it is. It's just the only multiplication there is. So e to the x times x to the third. And then add that to the final one, which is e to the x times 3x squared. So that would be 3, move the coefficient to the front. times e to the x, so 3e to the x, times x squared, so 3e to the x squared. And then we're just going to subtract that by what we have here, 2x to the fourth, e to the x. I rewrote it as 2 e to the x to the fourth down here, because to go along with a trend of having e to the x before x to the whatever power. And then that's all going to be over x squared plus 1, which is because, and that has been constant among all these steps, because in the quotient rule, as you know, in the denominator, you just take the denominator, not deriving it, and then you square it. So after you got this step, you can you're going to multiply these two together, and because of simplifications and factoring out, we can factor out 3 e to the 2x, x to the fifth from here, which is what this numerator is actually equal to, because it's 3 times e to the x times x cubed, but the x cubed is squared, so it's 3 e to the x, oh sorry, e to the 2x, because the e to the x is squared as well. So 3 e to the 2x, x to the fifth, times what's remaining from here after factoring out, which is just 3x squared plus x plus 3 minus 2x squared. And that's all over x squared plus 1 to the third. And the reason it's to the third is because over here we have x squared plus 1 squared, and over here we just have x squared plus 1. So multiply those two together and you get x squared plus 1 to the cubed, or to the third power. And then after doing that, just to reorder it to make it more organized, we have our final answer, which is f prime of x is equal to 3 e to the 2x, x to the fifth, just brought that down, multiplied by x cubed, which is right here. I just reordered these to make it look more organized. So x cubed plus x squared, and the reason why it's just x squared is because we got 3x squared here and negative 2x squared here. Combining like terms, you just get x squared. And then down here you get, once again, plus x, and the x is right there, you just brought that down, and then the 3 is right there, just brought that down, so plus 3, and then all over the same denominator as the prior step, which is x squared plus 1 all to the third.